not you. We. Good afternoon, everybody. Am I clear enough? It is my pleasure this afternoon to introduce, or rather to welcome back to summer school, a summer school favorite and regular, Professor Don Kurtz. Professor Kurtz is originally from San Diego, California. He was born to an American father and a Canadian mother. He obtained his PhD in astronomy from the University of Texas at Austin in 1976, and he spent the next 24 years in South Africa at the University of Cape Town, where he was professor and life fellow. Don has been professor of astrophysics at the University of Central Lancashire since 2001. He is frequently invited to speak internationally to both professional astronomers and the general public. So let us give him a welcome.
Let me get wired up here. Now, when Zuleha says I get invited to speak at a variety of venues around the world, did you notice the Queen Elizabeth was in port this weekend? That's how I got here. For me, it was a free trip to Cape Town. Yes, I lectured on the ship, and for my wife and me, we get a free trip to Cape Town, so it's a real bargain getting here. Well, I'm very pleased to be back. I always like to come back. This is home. I mean, I've now been living in the UK for 18 years, but after 24 years in Cape Town, South Africa is still home. And my wife is South African. You know, we astronomers often get asked a very tough question, frequently by politicians. Am I not loud enough for you? You need some more volume. Let's see if we can help. Oh, can you bring my volume up at all? It's actually, oh goodness, the farther from your mouth, the louder it is. Does that make it better for you? Is it too loud for some of you? Yeah, we're getting echo. Let's try to take it up a bit further. How's that?
Can you just
stay away from this?
Yes.
Okay. Why don't you put that somewhere else? Okay. I don't like to be behind that. We get asked this very hard question, what good is astronomy? And when the politician asks me that, he or she means, how can we use it to make money? I have many good answers to that. When I was young, just doing astronomy at the University of Texas, we were developing detectors to take pictures of the sky called charge-coupled devices. That's what makes your camera in your phone now. Everybody's got a CCD in their pocket. There were two developers of that technology, the military and the astronomers. The military keeps everything secret, so industry took it from the astronomical development. When I was a child, celestial mechanics about how things move in the sky was mathematics, physics, no practical application. You've all got GPS on your phones. Everybody's got GPS, and that GPS is just the technical development that came out of the astronomy that we were doing all those years ago. Now, when I was here at the University of Cape Town, I had many, many students take introductory astronomy from me, and I would like to argue one good of astronomy is that those people go on to do other things. I had a student named John Norris. He's a vice president and chief engineer of Anglo-American now. I had a student named Richard Ashley who did some research with me. He's got a senior position with Google. Here in South Africa, the professor at the University of KwaZulu-Natal, the professor at the University of the Northwest, senior lecturer, University of Cape Town, professor in engineering at Cape Town, they're all previous students of mine. Astronomy's got some practical applications. But that's not my favorite answer. I gave a talk to a farmers' society in England a couple of years ago, and one of the farmers asked me that, what good is astronomy? And so I said to him some of the things I just said to you. But what I mainly said is what you should do in a country that has enough money, and that may not be South Africa, partly it is, but for the rich countries, China, the US, Europe, just fund scientists to go out and find out how the world works. And out of that, you never know where it's coming from, will come great discoveries that have got great economic benefit, but you can't see ahead of time where that's coming from. And he said, oh, you know, I understand that completely. He said, my wife's got 25 racehorses, and you never know which one's going to be a winner. You know how much a racehorse costs? Wow, the farmers live in a different world. Now, I would like to show you a man that you may know the name of, you may not. Howard Florey. Well, you certainly know Alexander Fleming. Fleming, who discovered penicillin. But Fleming did not take penicillin into medical use. That was done by Howard Florey and his team. And Florey said, people sometimes think that I and the others worked on penicillin because we were interested in suffering humanity. I don't think it ever crossed our minds about suffering humanity. This was an interesting scientific exercise. And because it was of some use in medicine, is very gratifying, but that's not the reason we started working on that. How many hundreds of millions of people have benefited from and survived thanks to this man and his team's work? But he didn't see that coming. My grandmother died at the age of 25. My mother never knew her. Diphtheria. Today, we'd give her antibiotics. She would survive. So there's a case of completely undirected science with major, major impact for all of us. Just last year, the latest Nobel Prize in medicine, I got this quote from an interview from the man on the day it happened. Name's James Allison, and as soon as he got the Nobel Prize, he was at a hotel in New York City, and A.S. is the interviewer, calls him up and says, you didn't actually set out to find a cure for cancer. Was this basic research? And Allison, who's still very worked up about this, he's in his hotel room, he's being inundated as best he can over the phone, says, no, no, no. I was trying to understand how T cells work. We figured out this one thing about this negative regulator, had this idea that if we just took that off, you know, maybe it would do a better job of killing cancer cells, and sure enough, it works. So my message right at the moment is, for countries that can afford it, just fund scientists to go find out how things work, and somewhere you'll get amazing discoveries. You don't know where they're coming from. And that's really our story for today in astronomy. This is a beautiful picture from the Hubble Space Telescope of a cluster of stars in the Large Magellanic Cloud, which is a familiar friend to you in the night sky here in the southern hemisphere. Humans have looked up at the skies ever since we've been conscious and asked, what are the stars? Can you see any practical benefit to answering that question? What good would it do to know what the stars are? Well, let's find out. Our story begins on the 25th of May, 1543, in a cold stone room in a tower in a fortified town just south of modern-day Gdansk in Poland. A 70-year-old man lay dying from a brain hemorrhage. He was in a semi-coma, lying on his bed, when into the room walked his assistant, carrying the book that was the man's life work. It was placed in his unfeeling hands. He never regained consciousness to know that it finally was published. His name was Mikołaj Kopernik. We know him by the Latinized version of his name, Nicholas Copernicus. The book De Revolutionibus Orbium Caelestium, on the revolutions of the heavenly spheres. What did Copernicus do? He put the sun back at the center of the solar system. And for people then, that was the center of the universe. What do I mean he put it back? 2,000 years before Copernicus, the Greeks had a model of the universe with the sun at the center of the solar system and the universe, and the planets orbited the sun. And then the greatest authority of antiquity, Aristotle, looked at that and he said, look, if the Earth is orbiting the sun, here's the sun, when the Earth goes from one side of the sun to the other, the stars should wiggle back and forth. And they don't. You can look at them. They don't wiggle. And so that can't be right. The Earth's at the center. And that killed physics for 2,000 years. It really just stopped physical advancement for 2 millennia until Copernicus came and put the sun back at the center of the solar system. He also was able to build a scale model of the solar system. And let me just show you briefly one way he did that. Now, I have to warn you, you've been brave to sign up for this course. UCT always asks me, get us some new material, do some new things, and we are going to have some science through the week in addition to all the descriptions. I promise not to remain embedded in the diagrams and equations, but they'll come flying by at times for those of you who enjoy them. This schematically is the sun with Mercury, Venus, and the Earth orbiting the sun. Venus is up nicely in the morning sky right now for those of you who get up and look to the east. And if you look from the Earth, there's a maximum distance that Venus can get from the sun in angle because of the size of the orbits. It's 47 degrees. And as an astronomer, it's easy for me to use trigonometry to discover that the distance Venus is from the sun is 72% the distance that the Earth is from the sun. Copernicus could do that too. You could actually just draw a scale model of the triangle and measure it with a ruler. You can do the same thing for Mercury. With it never gets more than 23 degrees from the sun. And so Copernicus did that, and look how well he did. He had a little bit harder job with the outer planets, but he could do it. The distance the Earth is from the sun we define to be the astronomical unit, so that's 1 by definition. And there's Mercury, Venus, Mars, Jupiter, and Saturn according to Copernicus, and here are the modern values. And other than Saturn, the furthest of the planets he could see, look how well he did. At the time of Copernicus, 450 years ago, we had a complete scale model of the solar system. But we had no idea how far away the sun was. Nobody knew what it was or how far away it was. And so there was a puzzle to be solved. Well, Copernicus is perhaps the least colorful human who has ever shaped the course of history. Following Copernicus came the most colorful astronomer of all time. He was a Dane. His parents called him Tycho Brahe. We Latinized that to Tycho Brahe, and then in English I anglicize it and call him Tycho Brahe. You'll hear his name pronounced in many different ways. Tycho was born in 1546, so 3 years after Copernicus died. Let's put that in perspective in terms of English history at least. 1546 is the year before Henry VIII dies. And so Tycho's life spanned the Elizabethan years. His father was the governor of Helsingborg Castle. We call it Elsinore in English. And any ship coming into the Baltic, where the Hanseatic League ruled over commerce in Northern Europe, had to pass by Helsingborg Castle and pay a very large tax. Tax mostly went to the crown, but quite a bit of it went to the Brahes. They were incredibly wealthy. The governor, Otto, and his wife, Bertha, agreed with the governor's brother, Jorn, this is going to get complicated for the family, that when Otto and Bertha had their second son, it would be passed to Jorn to raise as his own because Jorn and his wife could have no children. And as luck would have it, the very first children that Otto and Bertha had were twin boys, with Tycho, the second one, out. But before the boys were weaned, the eldest died. And Otto and Bertha obviously are not giving up their only child to the brother. The brother is incensed. He threatens a duel to the death over this boy. Calmer people get them to settle down, and Jorn just waited until another boy was born, and he sent over some henchmen to take Tycho. Jorn was an admiral in the Danish Navy, and he just kidnapped the boy. The two brothers became reconciled again, and so Tycho was raised by his paternal uncle. And the uncle was very wealthy, very much connected with the royal family. And one day, after a battle with the Norwegians, which the Danes won, the king was riding his horse back across the low bridges to his castle in Copenhagen when his horse threw him into the sea. And Uncle Jorn jumped into the sea and saved the king's life, but he caught pneumonia in the process and died of it. And the king was extremely grateful, and he bestowed his gratitude upon the son, Tycho. Tycho was given so much money and so many things that he became the wealthiest person in Denmark outside of the royal family. So this is an incredibly wealthy man. In his teenage years, he was captivated by a total eclipse of the sun. He could not believe that astronomers could know the position of the moon and the sun so well that they could say at this minute, at this time, in this place, the moon will cover the sun and block it out. He was expected to grow up and rule a castle, mink and manure and all that. But he loved astronomy, and he went to university in Germany and became very good at mathematics and physics. Until at 18, he and another boy got into an argument at a party at their professor's house. Now, you know what two 18-year-old boys get in an argument about. It was the proof of a mathematical equation. And their solution to this was to have a duel to see who was right. It's not the way we decide mathematics anymore. Tycho lost the duel. He did not lose his life, or I wouldn't be telling you about him, but he lost almost all of his nose. Take my glasses off. This entire bridge in here was cut out of his nose by the other boy's sword, so only a little bit hung off the end. And for the rest of his life, Tycho had gold and silver blocks that he waxed into place and held on with a strap, and he was very proud of them. Now, the artist who made this drawing in 1586 was not the world's greatest artist. Tycho did not have two left hands. That's just a mistake. But he did have a gold or silver nose. He was given on an island called Havane, and it's right off of Copenhagen. If you fly out of the Copenhagen airport, the flight path takes you right over the island. You look down on it. He had all the income off of all the farms, and he was a despot. He overtaxed his people. If they couldn't pay the taxes, he would put families, children, mother, father, in chains in his dungeon. While at the same time, he would have big parties. And Tycho had a pet named Jep, and Jep lived mostly under the table. Tycho threw him scraps from the dinner. But Jep wasn't a dog. Jep was a human dwarf. There was nothing wrong with his mind. So when you went to a party at Tycho's place, you really needed to be careful. Now, you know, you go out to dinner party and you come home and you turn to your husband or your wife or whomever you're with, and now did you see what she was wearing? And the gossip starts. After you get home, well, Jep didn't wait till you went home. Jep would let loose at anybody there. He could say anything he liked. Tycho loved him, and you just didn't want Jep coming after you at the party. That was only on cloudy nights. On clear nights, Tycho observed every clear night for 20 years. And what he could do is he could measure the positions of the stars and planets to 1 minute of arc, a 30th the diameter of the moon. He had the feeling that precise measurements of positions in the sky would give him the answer to life, the universe, and everything. And he didn't agree with Copernicus. He wanted to prove Copernicus wrong and his own model right. He was so extremely well known in Europe in his lifetime that the greatest Englishman who ever lived was well aware of Tycho. Who's the greatest Englishman who ever lived? William Shakespeare, born in 1564. When he got older, he wanted to write a play about a Danish nobleman set 400 years before his time. Shakespeare didn't have a telephone directory for Copenhagen. Where does he get Danish names? If you look along this picture, the artist has put the names of Tycho's family ancestors along the outside, and you will find Rosencrantz and Guildenstern. This has got to be where Shakespeare got it. He would have been so aware of Tycho with his fame in Europe. Tycho built a palace and an observatory. This is called Uraniborg on Havane. There's the palace. These are very traditional French gardens, the walls around the outside, and his observatory. But his observatory did not have telescopes. The telescope hadn't been invented yet. He had great sighting devices, like giant gun sights. And they were so big. This one was about 15 meters long. The artist has put many things into the picture, not all to scale. But the sighting devices were so long and so precise, he could get these measures of the positions of things in the sky. He did that for 20 years. Then the king died. Now, I trust you all know the names of the kings of Denmark for the last 500 years. Let me teach them to you. Frederick, Christian, Frederick, Christian, Frederick, Christian, Frederick, Christian, until the current queen. Frederick II died, and King Christian IV, his son, became king as a teenager. Tycho had watched the boy grow up. He was kind of like a nephew. But the people on Havane petitioned the new king, please get this man to lower our taxes and stop abusing us. And Christian said to Tycho, lower your taxes and leave those people alone. Tycho ignored him. The king told Tycho 3 times what to do, and Tycho ignored him every time. You can do that to a kid growing up, but you can't do it once he becomes king. And so the king did something terrible to Tycho. He did something so terrible that everybody in the world today now, if it happens to them, they're totally distressed. He cut Tycho's salary. If you don't believe me, take any banker in London who gets $2 billion a year in bonuses and cut his bonus to $1 billion, and you got a miserable person. So Tycho was so incensed at having his salary cut, he changed jobs. He took the job as imperial mathematician to the Holy Roman Emperor in Prague. And so in this graphic, here's the island of Havane, just off of Copenhagen in Denmark. There is where Copernicus was, up here in Gdansk. And Tycho just migrated down to Prague, where he became the imperial mathematician to the Holy Roman Emperor Rudolf II. Rudolf was not a great emperor, but he liked to collect oddities. He liked to collect art. One of the oddities he collected was Tycho. The art that he collected, he had an artist, an Italian artist named Arcimboldo, and because of the Swedes having sacked Prague and distributed the art, Arcimboldo's paintings are now in the Art Museum in Vienna, where you can see them. And Arcimboldo painted Rudolf, and Rudolf loved the painting. I don't know if you do. I think it's rather quaint with the vegetables and fruit, giving us a picture of Rudolf. So Rudolf is strange, and he's collected Tycho. Tycho comes to Prague, late 1500s, and he now wants to use his observations to discover the answer to everything. But this is not easy. There are no computers. There are no calculators. There are no slide rules. All calculations are longhand. And he's an important person. He's working for the emperor. He doesn't have time. He needs an assistant. And so he hires an assistant from Germany. His name's Johannes Kepler. And we're going to meet Kepler in more detail tomorrow. Kepler, totally different from Tycho. He grew up in a fairly poor family. His father was a mercenary soldier. He'd go off to war, come home. Father and Mother Kepler would have another child. Father would go away to war, come home, there'd be another child. And this went on until they had 8 children. And then Father Kepler didn't come home again. Nobody knows what happened to him. Maybe he died in one of the wars. Maybe he had another family somewhere else and decided he preferred them and didn't come home. But Kepler grew up in a rather impoverished environment, but he was brilliant. At university, he was brilliant, made a real name for himself. Tycho hired him to come analyze the observations. The problem was that Tycho didn't want Kepler to be the person who discovered the answer to life, the universe, and everything. He wanted Kepler to do the work, but not find the final answer. And so Tycho gave Kepler the hardest problem. He gave him Mars. Mars is hard because it's very eccentric, and we'll learn more about what eccentricity means tomorrow. But it also was the key to the answer. And so although he gave Kepler something very hard to do, he also gave him exactly what was needed to find the answers. Kepler didn't find the answers during Tycho's lifetime, but Tycho's lifetime wasn't very much longer. He died tychonically. He lived a bigger-than-life life, and he died in his own unique way. He was at a party at a local baron's house in Prague, and Tycho was a big man, and he loved to drink, as many people did. Huge tankards of beer, you know, these big German tankards. So he's been drinking lots of beer during dinner, and he really did need to get up and go. But his host was speaking, and Tycho had good manners. Such good manners that he held until he burst his own bladder. It took him 5 days to die from it. He died in absolute misery, fever, and during his 5 days of delirium, he kept saying, "Let me not seem to have lived in vain." And he didn't live in vain. Remarkably, I'm telling you about his observations now. Kepler didn't inherit them directly. Tycho's son-in-law, Tingnagel, inherited them, and he offered them to Kepler if Kepler would make Tingnagel a co-author on all the publications. If any of you are academics, this sounds familiar. Oh boy, you know, get a bit of leverage there and force your students to put your names on their papers. But Tingnagel also got money with the observations, and Kepler said, fine, you can be a co-author, but I should get part of the money. And Tingnagel was so greedy, he said, no, just here, you can have them. And you've never heard of Tingnagel, whereas Kepler's names reverberated down the centuries. And so Kepler worked on these observations for almost 20 years. His first book, I don't know how I got to Newton, his first book, I'm going to tell you the story tomorrow of his book. Sorry, I forgot which lecture I was telling you. His first book took 8 years, and the next one took 10 years. I don't want you to think of Kepler as calculating, sitting at a desk by candlelight. Kepler only calculated standing up. His piles were so bad he couldn't sit. He was in poor health his whole life. And so he stood in painful misery, standing, calculating for almost 20 years. And I'll tell you that story tomorrow. He discovered his 3 laws of motion. Now, just following his death, 1630, 1642, 12 years later, was born Isaac Newton. Newton, perhaps the most brilliant mind ever, at least in the sciences. There are different kinds of intelligences. How can you compare the intelligence of Isaac Newton with the intelligence of Beethoven? It's totally different fields of human intelligence. But at least in physics, this is perhaps the smartest man there ever was. Don't feel too envious. He never had a friend, and he lived a long life. He didn't have a girlfriend, a boyfriend, a partner, a close companion. He probably would be on the autistic syndrome spectrum somewhere today if we were to look at him more carefully. But look what he did. In his 20s, he invented his 3 laws of motion. An object in motion keeps going unless there's a force on it. Force is equal to mass times acceleration. He invented calculus. It didn't exist and he needed to learn it. Well, he didn't learn it by being taught it. He invented it. And then he calculated how the planet should move. He invented the law of gravity. Now, that law of gravity, for those of you who don't like equations, we can put any equation into words, and it just says the force of gravity, the more stuff you've got, the more force you have. The bigger the mass, the more gravity. That seems intuitive. I have to tell you, that's not true of the strong nuclear force. And so the whole universe doesn't always work like that. But to Newton, it seemed intuitive. It's true for gravity. So this is just how much mass one body has and how much mass another body has. The force reaches out into space and it spreads out into a sphere. And if you can remember back to your school days, the area of the surface of a sphere is equal to 4 pi times its radius squared. So the force is dropping off with distance times itself, distance squared. Newton invents all of these things in his mind and then calculates how the planet should move if gravity's holding them around the sun, and he discovers Kepler's laws. And he knew he was right because Kepler had already discovered them using observations from Tycho. Now, I want to take you back from Newton. I put Newton's dates of 1642 onwards. We're going to see in the last lecture that 1642 is a bit arguable, because that was a time before the calendar that we use, and as far as Newton's parents were concerned, he was born on Christmas Day, 1641. I'll tell you more about that in the last lecture on the calendar. I want to take you back in time a generation to this man. You must have noticed on the first slide, my institute's called the Jeremiah Horrocks Institute, and you said to yourself, well, who is Jeremiah Horrocks? And so here's the answer to the question. Jeremiah Horrocks, born into a family, his father was a watchmaker, a reasonable amount of money, but not very much, in Toxteth. At that time, Toxteth was suburban outside of the city of Liverpool. Liverpool had a population of less than 2,000 people, fewer than 2,000 people, in 1618. Horrocks is born there in 1618. Toxteth is now it's part of Liverpool. It's only 2 kilometers from the docks. He was not wealthy enough to be a student at Cambridge, but he was so smart that at the age of 13, he went to Cambridge as a sizer. And he paid his way through Cambridge by being a tutor to rich kids. So he learned this stuff and he taught the other kids. And what that meant was that at the age of 15, look at his age right here, 1618, when he's 15, we're talking 1633, Kepler had just died. And this boy, as a 15-year-old teenager, was the world master of Kepler's new astronomy. Nobody in the world knew that astronomy or could use it better than he could at age 15. He proved that the moon moved in an elliptical orbit, according to Kepler's laws. And he also noticed that Kepler had made mistakes, and Horrocks corrected Kepler's mistakes. He discovered that Venus would pass across the sun in 1639. Kepler didn't know that. He missed that in his calculations. And Horrocks succeeded in observing Venus pass across the face of the sun at the end of 1639. That turned out to be incredibly important in world history. Following that observation of the transit of Venus, Horrocks decided to meet his friend William Crabtree. They had only ever corresponded because they lived 50 kilometers apart, and that was too expensive to move between them. But Horrocks decided after the transit he had to go meet William Crabtree in Salford, which is near Manchester. He saved enough money to get a ticket to go by coach, and the day he was to go, he died. He was 22 years old. We have no idea what brilliant things this man would have done had he lived. But where he was working was as a tutor to a family called the Stones family in this house right here in Muchhool in Lancashire, and that is 12 kilometers from my office. And so we thought we would resurrect this rather forgotten genius of a past time who was local for us. In 2004, there was a transit of Venus, and for that transit, I ran an international meeting in my town of Preston. And during the transit, I took 100 astronomers from all around the world down to this house with the permission of the owners. And we went into the house and we watched Venus passing across the face of the sun from the very room that Horrocks watched it from. We had the BBC there, Patrick Moore, if you remember Patrick with his Sky at Night program. And we had a clear day. It was kind to us. We watched the entire transit. Transits are rare. Venus passed across the sun in 1631 and 1639. Kepler predicted that one, nobody watched. Horrocks predicted this one, and he and Crabtree saw it. And then the transits didn't happen again for a century, 2, 8 years apart, a century, 2, 8 years apart, and so on. If you missed these two in 2004 and 2012, sorry, you're out of luck. Well, their medical changes are coming, but I'm not sure you're going to make the next one. I watched the 2004 transit. Those became incredibly important in science. Now, where did the push come from? In 1660, in England, Charles II was restored to the crown after the English Civil War of the 1640s, and then the king comes back in 1660. And why do I show you a picture of the Millennium Bridge in St. Paul's? Well, because there was a group of men, and lady, I'm sorry at that time, it was a group of men who founded the Royal Society. That's certainly not true now. The Royal Society has many, many women scientists, and they're very strong in the Royal Society. Times have fortunately changed. At that time, this small group of men founded the society. Isaac Newton, one of the founders of the society, was the civilian professor of astronomy at Oxford until he was 29. And then at 29, he changed careers. His name you know well, and that's why I show you this picture. He's buried in St. Paul's. If you've been to St. Paul's, you go down into the crypt, you can find this plaque his son put up to him, Christopher Wren. And the plaque says, "Reader, if a monument you seek, look around you," meaning St. Paul's is the monument to Christopher Wren. So Christopher Wren, Isaac Newton, Edmund Halley are forming the Royal Society, and they're looking for scientific problems to solve. Well, if the English have got a Royal Society, well, the French are going to have one too. And so shortly thereafter, the Académie Royale des Sciences formed in France, and my goodness, the French and English never do things the same way. In France, Louis XIV's on the throne. Colbert, his minister, has got loads of money to work with, and Louis XIV just says, you get the best scientists, you build the best observatory, we're going to have the best of everything. And so the old Royal Observatory, now the Observatoire de Paris, is built, not too far from the Jardin de Luxembourg today. Foucault does his first experiment with the pendulum that shows the Earth rotates inside this building. Sumptuous rooms, beautiful offices, fine French food, and the French stock that the way a modern football team buys players. They just went out and offered huge salaries from scientists all over Europe to come work there. They tried to poach Isaac Newton, and he didn't take the money. He stayed in England. So the French have got this beautiful observatory with no expense spared, and so the English have to have an observatory too. They build the Royal Greenwich Observatory on the cheap. It's funded by the sale of spoiled gunpowder by the Navy. There's some old bricks from a previous building that have been knocked down, and they got some wood from a gate from the Tower of London and used that for the wood. They had one astronomer royal, one assistant, and the assistant made £24 a year. And even then, that didn't go very far, and that's it. So the French have stocked the best scientists in the whole world that they can get for their sumptuous observatory, and the English build something on the cheap, and they've got 2 people. But the science came out of the English observatory. I love France. I've lived there for a year, but when one spends all one's time dining, sometimes the science doesn't get done. Well, their main problem of that century was, how do you determine your longitude at sea? They know how to do latitude, but how do you determine your longitude? You need good time. And of course, here in Cape Town, the time ball's still there down in the docks. The noonday gun still goes up. That's in this tradition. And many of you will have read Dava Sobel's book on longitude. The solution didn't come from the astronomy. It came from James Harrison building his marine chronometers, which could keep time at sea. Harrison's clocks are almost priceless. and some of them belong to the Royal Astronomical Society. I recently was the vice president of that society. I've sat on the council, and it's a charity. And when you're on the council of a charity or the board of a charity, you're legally responsible for the possessions of that charity. And I tell you, I find it somewhat frightening to be legally responsible for things that you can't put any price on. But we're proud owners of those clocks. They're on permanent loan to the Maritime Museum in Greenwich, and you can see them there. These two royal societies now have a problem. The next century, what do? What's the next big scientific problem? And Edmund Halley answered that. Halley was the civilian professor of geometry at Oxford. He was the one who pressured Newton to publish his fabulous Principia, which laid out modern physics. Physics we all still use. If you'd like to see the one and only copy of Principia, it's in the hand of Newton's secretary mostly, but some in his own hand, and it sits in a glass case in the Royal Society headquarters on Carlton Terrace, just at the bottom of Regent Street, just above the Mall in London, and you can go in the door and have a look at the original if you'd like to. It's there. Newton donated to that society when he died. Halley looked at the coming century, and he said, what we need to do, the most important scientific problem, how far away is the sun? What is it? And that's what the two scientific societies decided to tackle in the 18th century. Halley knew how to do that, and he knew it because he learned it from Jeremiah Horrocks. Watch Venus passing across the sun from different places on the Earth, and you can triangulate. That was the big problem for the next century. Here from 2004 is what a transit actually looks like. This is taken with the Dutch Open Telescope in the Canary Islands. It's sped up. You can see the time flying by. It takes Venus about 6 hours to cross the sun. But if you're in a different place on the Earth, not in the Canary Islands, it crosses a different path. And if you time how long it takes to cross, you can tell exactly what latitude it's at on the sun. And so graphically, here's the solution to the problem. Watch Venus pass across the sun from some place like Spain and West Africa, and you'll see it pass across different chords. Time them, and that will give you the latitude on the sun. And then the difference in the latitudes tells you this angle right here, and these two lines cross, so it's the same as this angle. If you've surveyed your position precisely, you now know the length of that side, you know all the angles, you can solve the triangle, and you now know the distance to Venus, and Copernicus told us how far Venus is away from the sun compared to the Earth. And so you now know how far away the sun is. That's the challenge for the 18th century. When the time came, 1761, expeditions were sent all over the planet by all the big European powers. England, France, Russia, Germany. They're sending astronomers all over to observe transits of Venus from different places. The English send out in 1761, Charles, who's the assistant astronomer at the Royal Greenwich Observatory, still only making 24 pounds a year, as his predecessor did a century before. Very little prospect in life. He was thrilled with the chance that he could be the lead astronomer on this expedition to go all the way around Africa and out to Bencoolen in Sumatra, which is where the Royal Society wanted him. He needed an assistant, and there were so few astronomers he couldn't find one. So he got an assistant named Jeremiah, who was a surveyor from County Durham, and Charles and Jeremiah sailed out of Southampton on the HMS Seahorse. Now, I sailed out of Southampton just a couple weeks ago on the Queen Elizabeth. My experience was very different from theirs, but it was the same path. They thought they would be about 1.5 years to go around to Bencoolen, make their observations, and sail back again. But they were wrong about that. They were back 3 hours later with 11 dead and 37 wounded. This was during the 7 Years' War, and the Seahorse had sailed into the guns of the French ship Le Grand. The French are not modest in the way they name their warships, the big one. And Le Grand pretty much blew the Seahorse out of the water. Not quite. They limped back to Southampton, and Charles sent a letter to London to the Royal Society. Letters went quickly, even back then, from Southampton to London, and said, "We will not proceed thither, let the consequence be what it will." And the Royal Society responded immediately with a letter back to Charles and Jeremiah saying, their refusal to proceed after having so publicly and notoriously engaged in it would be a reproach to the nation in general, to the Royal Society in particular, and most especially and fatally to themselves. Could not fail to bring an indelible scandal upon their character and probably end in their utter ruin. They didn't stop there. The society noted that it would, with the most inflexible resentment, prosecute them with the utmost severity of the law. Charles and Jeremiah saw things in a different light. And so when the ship was fixed in February 1761, they were on it. And out they went, down the Solent, past the Isle of Wight, with a better naval escort this time, no French. They sailed down the west coast of Africa, same path I just came down to get here this week. And they put into Cape Town, of course, to provision themselves. Water, food. In they come to Cape Town. Beautiful time exposure on Table Mountain. And they discover, much to their delight, the French have taken Bencoolen. They can't continue, and they can do their observations of the transit from Cape Town. So they observed from the parade, and the day was clear, the sun was out, they watched the entire transit, and they surveyed their position in Cape Town so well that the Royal Navy then knew the distance from the Royal Greenwich Observatory to the observatory here in Cape Town better than they knew the distance from the Royal Observatory at Greenwich to Paris. Charles and Jeremiah were famous throughout the British Empire as surveyors from this astronomical observation. Well, 1760s in North America, it was still the colonies, and two of the colonies, one ruled by the Penn family, called Pennsylvania, the other ruled by Lord Baltimore, called Maryland, had been having a court battle for a long time about the boundary between their two colonies. The lawyers finally agreed in 1763, and they said, we want the best surveyors in the British Empire. Get Charles and Jeremiah over here to survey this boundary. So over comes Charles and Jeremiah, and for 4 years they just survey due west, a line dividing Maryland from Pennsylvania. And when they finished, it was named after them. They were Charles Mason and Jeremiah Dixon. It was the Mason-Dixon line. It divided north from south, free from slave state, and the entire South. And y'all can hear I'm from the South. I did my PhD in Texas and Austin. Would you like me to give you the talks in Texan? The whole South is Dixie, named after Jeremiah Dixon. You listen to Dixieland jazz, comes right out of transits of Venus, trying to find out how far away the sun is. They did a good job, but we scientists are never happy. We want more precision, better observations. 1769 is another choice, so more expeditions are to go out. And this time for 1769, the transit's on the other side of the planet, in the South Pacific, which Europeans have only just discovered from the European point of view. Very few ships had been there at that point. The Royal Navy takes an old colliery ship, a ship that was used for hauling coal. They're very round bottom, they're not very seaworthy, and they decided to outfit it for an expedition to the other side of the planet to watch a transit of Venus with some astronomers. They couldn't get any Royal Navy captain to take command. The Royal Navy captains looked at that and said, I'm going to take command of this little thing wallowing in the water to take some scientists to look at some weird thing in the sky. That's going to do my career no good. So eventually the Royal Society persuaded a lieutenant who had been making a bit of name for himself surveying the St. Lawrence River in Canada. They persuaded him to take command of the ship, and it sailed out of Whitby in Yorkshire. The ship's name was the Endeavour. The captain was James Cook. It was the greatest expedition of discovery of all time. Talk about a career-making move. I hope all those other Royal Navy captains ate their hearts out the rest of their lives. And so Cook took the two astronomers, Green and his assistant, and also Joseph Banks, with all his discoveries of plants. So for those of you who know Banksia Road down here, of course the Banksia are named after Banks. He took them out to Tahiti, this island that the Europeans didn't know yet, to observe the transit of Venus. And if you go to Tahiti, you go to Papeete, just up the coastline about 20 kilometers is Point Venus from where they made the observations. The observations were successful. Not all expeditions went so well. Now, these are the two Royal Societies battling it out to try to make this big discovery, the distance to the sun. And I want to just tell you the sad story of a French astronomer who attempted to be part of this, sent out by the Académie Royale. His name is Guillaume Joseph Hyacinthe Jean-Baptiste Le Gentil de la Glacier. That is such a mouthful, we're just going to call him Le Gentil, the gentle. And there's his book, Voyage on the Indian Ocean by order of the king on the occasion of the passage of Venus across the disk of the sun on the 6th of June, 1761, and the 3rd of the same month, 1769. There goes Le Gentil out. He's wealthy, he's Parisian, he's sophisticated, he loves culture, and he sails to this terrible place called Ile-de-France. We call it Mauritius, and we don't think it's so terrible. But there weren't any resorts there back then. He gets to Mauritius, and from there he decides, no, I should observe from the Philippines. So he sails to the Philippines, where the 7 Years' War is still on. The governor of the Philippines throws him in jail as a spy. And it takes some months for the French government to extract him. Time's passing, the transit's coming, and he's ordered to get on the ship and go to India to watch the transit. And he doesn't make it. He's at sea the day of the transit. It's a perfect day. He watches it. He sees the transit, but he can't survey where he is. He's out in the ocean. His observations are useless. He now thinks it's 8 years to the next one, but it's really dangerous to go home. There's a war on, so he stays. And he spends his 8 years surveying the islands that we know, Mauritius, Reunion, Madagascar, until finally 8 years later he goes to Pondicherry, a French protectorate in India. He builds an observatory, the Maharaja hosts him, and he's got a beautiful observatory. The night before the transit is perfect. It's clear, the wind is calm. Le Gentil goes to bed and he wakes up in the middle of the night to howling wind, pouring rain. And the next morning, for 6 hours, the rain poured and the wind blew and the clouds blocked the sky during the transit. And just as the transit finished, the skies cleared, the sun came out. He got nothing. So he sailed back to Ile-de-France, packed up his stuff to go home, when a British man of war sailed into Port Louis. And Le Gentil went down and showed a piece of paper to the captain from the Royal Society saying, this man is a scientist, do not molest him. And the captain scuttled his ship. He was marooned. Until a Spanish ship came by, he hitchhiked a ride home on a Spanish ship, which came around, provisioned in Cape Town, headed up the coast, and it got taken by a British man of war. British captain comes on board his conquest, the Spanish ship, and the Spanish captain says to him, look, the war's over. We're friends now. And the British captain said, oh, come on. I mean, you can't, that's the oldest trick in the book. But the Spanish captain had newspapers. He'd picked them up in Cape Town. It was true. And so the Spanish and the British had a bit of a party, and they traded potatoes for sherry and continued on their way. Le Gentil got to Portugal. He just said, I'm getting off the ship. He walked home from Portugal. He walked into Paris, and people were amazed to see him. The town was small. They recognized him, but he had been declared dead. All of his wealth had been dispersed to his heirs. He had lost his seat in the academy. Well, the academy gave him a special seat, and through the courts he reacquired some of his wealth, and he lived happily for another 22 years, if you look at his dates, but he never did astronomy again. No more astronomy for him. Another Frenchman took all the observations, Lalande, he put them together, and he discovered the distance to the sun. He got 153 million kilometers. It's not too bad compared to the modern value. Look at the insane precision we have on the modern value. But all of a sudden we know how bright the sun is. We've got its distance. It is 384 septillion watts, whatever that means to you or me. It's insanely bright. Well, that's a complete surprise. And then, near the same time, next century, parallax is finally discovered. We've overcome Aristotle. The Earth moves around the sun, and just as my finger goes back and forth when I blink my eyes, we can triangulate the distance to the stars. First person who ever makes the measurements to do that, one Thomas Henderson, the second director of the observatory here in Cape Town. And then Bessel and Struve do a similar thing, and we discover how far away the stars are. Alpha Centauri is 4.3 light years away. Alpha Centauri is as bright as the sun. And so the question now is, what powers the stars? That's the big question of the 19th century in physics. What powers the stars? Could it be chemical? What if the sun's made out of hydrogen and oxygen and they're just burning to make water? Well, the sun is so big that it could do that for 5,000 years. But the sun and the earth are a lot older than 5,000 years. Lord Kelvin Helmholtz in Germany do what we call the Kelvin-Helmholtz calculation. And my undergraduates in first year learned to do this very quickly. And so to an undergraduate physics student, this is easy. If it's not to you, it just says the time the sun can shine is equal to the energy available due to gravity, which is the gravitational constant times mass squared over the radius, divided by the rate at which it uses up its energy. And we calculate that and we find the sun could shine for 20 million years at its current brightness if it's just getting its energy from gravity. You know, if I drop this, I'll break it. Energy's released. The sun's a whole lot older than 20 million years. This isn't the answer. So what powers the stars? There's the puzzle. Come the turn of the century, the beginning of the 1900s, beginning of the 20th century, Marie Curie, Jacques Becquerel are discovering radioactivity. 1905, Albert Einstein has 4 fundamental discoveries, one of which, in his paper on special relativity, he shows the equation you all do know, that energy and mass are equivalent, E equals mc squared. Then Sir Arthur Stanley Eddington, we'll meet Eddington a little bit more. Eddington proposes that the sun might be made of hydrogen, and hydrogen, the lightest element, might be fusing to make helium, and that could be the source of the power of the stars. It's a conjecture, because we don't know what the sun's made out of, until just a few years later, Cecilia Payne answers that question. Cecilia was a young English woman. She married a crazy Russian named Gaposchkin, so she was Cecilia Payne Gaposchkin through much of her career. But as Cecilia Payne, she wanted to be an astrophysicist. And as an English woman, she wanted to go to Cambridge and Oxford. Cambridge and Oxford did not admit women. She went to Harvard. They did admit women, but not as full human beings, but at least they could come study. And she wrote the most important thesis ever written in astronomy. She showed that the sun's 90% hydrogen, and by inference, the rest of the universe. And all of a sudden, we now know that Eddington's conjecture is possibly right. How does hydrogen fuse to helium? That was finally answered next decade by Hans Bethe, who worked right up almost to the age of 100, and he was still doing physics right up to the end. 1939, he had finally figured out the pathways of how hydrogen fuses to helium. I was going to show you those rather complex pathways. Let me not do that, but tell you that the fusion of hydrogen to helium is what powers the stars. And let me put that in perspective. If you fuse 100 kilograms of hydrogen to helium, the helium has slightly less mass. 700 grams disappears. If you completely convert 700 grams from mass to energy, E equals mc squared, it will explode with the power of a hydrogen bomb. There's the first tests over Bikini and Inuiatek back in the 1950s. That's just a human's mass of hydrogen. The Russians went so far as to build this horrendous bomb with 50 megatons power. This is for perspective. I don't approve of these things.